All right, hey everyone, Dylan here from Sleeping with the Numbers, and today's video is going to be a little different than anything we've really been doing. It's not really a podcast episode. I think it's more meant to be seen visually. But this is how I developed our March Madness prediction model. Um, did this anyways for the podcast because we wanted to get a model, share some predictions there, but found out through some of my friends here that there was actually a March Machine Learning Mania 2022 Kaggle competition. And if you do not know what Kaggle is, you likely don't if you're not in the data science world or are interested in that type of thing. But Kaggle is a place. It initially started as a place where you could find data sets. People would upload data sets on really anything. And I would use this as a student when I took the boot camp. When I taught the boot camp, we told our students to use this as a good source to gather up some data so you don't have to go and find it, on your own with some web scraping, API calls, all that stuff, because that's time consuming. So instead, you usually go to Kaggle and you can grab some data sets there. So another thing that Kaggle does is they do different kind of competitions. So let me just click on some of the ones they have here. So there's some for feedback prize for evaluating student writing for something, I guess. Whale and dolphin identification. That's pretty cool. Bird identifying bird calls. So there's a lot of like data science, machine learning type competitions you can do here, and there's cash prizes, which is awesome. So for us, we're going to be doing the March Madness men's NCAA tournament. And I'm going to just show you how I quickly created a model here. Now, this is by no means anything fancy. Did this in a short amount of time. You can probably make a much better model than I can in the time I was given. But anyways, it's a starting point. And if you're interested in this world, if you're interested in data science, Python, machine learning in general, hopefully this can show you just the possibilities of machine learning, because it is a really cool subject. And underneath the hood, it is just statistics. So don't let that scare you. Statistics is fun. Math is fun. And these Python packages make it a bit easier, so you're not doing all the heavy lifting math on your own. So for this competition, they give you a bunch of data. They have the cities, conferences, regular season results, tournament season results, seeds, coaches, conferences, team names. There is a ton of data here to use to build out your model. So first thing I did, you download the data, of course. And so I just kind of jumped into it, did a little bit of data exploration. I looked through the CSVs to see like what type of data they have here. Some of it, you don't really care about. Do I care about the city? No. I don't think that has anything really to do with predicting a winner in college basketball. So conferences, yeah, maybe that's definitely a possibility. Some of the tougher conferences you might expect to be better, probably much so like football. If SEC team is playing usually anyone else, they have a bump because that is the conference to be in for the NCAA football at least. Basketball, I honestly don't know. I don't follow college basketball until it is March Madness time. So, anyways, ton of data here, and so I use this data. I downloaded it, and I popped open a Jupyter Notebook again. If this is new to you, highly recommend doing some of your own research and getting into Python. You'll find Jupyter notebooks almost immediately. I use them daily at work. I like to do all of my testing in them. You get immediate feedback, immediate output. Really just a great source to do some Python programming quickly. So I already ran through all this. That way we don't have to wait for my models to train and fit and all that good stuff. So I'm just going to run through what I did here, why I did it, the different models I chose, and the outcomes of those models, and then finally get into the final model. So here I'm importing some packages, and then I'm importing the data I used. So first I got the regular season data. And then here you can see I'm only getting the data from 2010 onward. I I don't know this to be a fact. I know it's a fact with the NFL because I've studied that a lot more than I have college basketball. Um, but I took more recent data. The game has probably changed, in the decades it's been played and since the tournament started. So I want more recent data to kind of take into account those changes. It's not the same as it was in the 90s, probably. And then here I was just kind of checking out the season for 2021, really just looking at the data here to see what it looked like. That's really all I was doing here. Next, I am doing quite a bit here. So I'm going through every single team ID. I am getting their data from when they were the winning team and from when they were the losing team. I'm grabbing their score, field goals made, 3 points made, free throw attempts. There's a lot of different data there, but I'm grabbing all their data. And then here, I am just changing the column name. So you can see here that the column name is W team ID, so the winning team ID. And then there's also L team ID. I don't want that. I just want it to be team ID so I can combine it later. So I do that. I get the sum of all the data. I get the count of all the data. The reason I do that is so I can get the average season data. And then I do the same thing down here for the losing teams. Combine them together. I add a little prefix here, so it says season average now, which you can see down here. So it's now the season average score, the season average field goals made. It's like that the whole way down, and you can see we have it for each team ID for every season that they were playing. Next, I'm grabbing the tournament data. So I have the seed data and the actual tournament detailed results. I'm running through that data, getting the team score, for each match they played in the tournament. Now, remember, not every team made it to the tournament, so that's going to filter out quite a few of these guys here. Going to concatenate that all together, sorted by the season, and then I am dropping any duplicates after merging on the seed data. So this way, I have the seed, which is obviously important. It's like the 1 is almost guaranteed to beat a 16. So obviously that data is important, unless you're Virginia, when you screw me and lose as a 1 seed to a 16. I'm doing a little string manipulation here on the seed, because if we look at the seed, let's go back to the seed data. Seeds. Nope, seeds. Here we go. You can see that they have the division as well, so West 1, West 2, West 3, so on and so forth. I don't care about that letter. So all this is doing is removing that letter. I'm just grabbing the numbers. Again, if you're interested in regex, which is a whole course on its own, feel free to look that up, or leave a comment, message me on Twitter, whatever you want to do. I'm always for talking about this stuff. It's super interesting to me, obviously. So here I am then merging it on the conferences, because I was curious if the conferences made any difference. Spoiler alert, it really didn't. And I turned it into dummy variables. So the first model I went with, which is the model I always start with, linear regression model. So here I am grabbing all of the data except for the season, team ID, and the score. And those are going to be our X variables. And then we are trying to predict the Y or the score. You'll see here that I move on from that pretty quickly. Next, I'm importing some scikit-learn models. That's just, like I said, if you don't want to do all the stats yourself, this is how you do it. Scikit-learn is a very common machine learning package that almost everyone uses. Next thing I do here, I am doing some ordinary least squared regression results, and I am removing all of the variables that are not statistically significant, or they have a p-value greater than 0.05. So that's all I'm doing here, just doing it programmatically. And here you can see all of the conferences that supposedly matter. This was a mess. I ended up getting rid of this. The results were not great. As you can see, when I split it between the training and the test set, fit it, and score it, it didn't do very well. Only about 18% correct, which is not great. So after realizing predicting the score was kind of pointless, really what we care about is who wins, right? And we're not trying to predict the spread here. I'm not betting the spread or anything from this model. This is all about creating a bracket. And when you're creating a bracket, you don't think about who covers the spread. You think about who wins. So from there, I switched gears and I moved into logistic. They should probably say logistic classification. It's a classification model. We're not doing a regression model here, like I said. So here, we're going to be predicting the win. So what I do from here is I am grabbing the tournament data, so the season, the winning team ID, the losing team ID. I am then grabbing all the data where it's not equal to 2021 because I want to predict 2021. That's where I'm doing my testing. So then I am merging it with the team's regular season average data. So this way I know how, on average, they did throughout the regular season before heading into the tournament. And then, of course, we add the seeds, do all the string manipulation, all that good stuff. The final field I make here is the seed difference. So I'm taking the seed of the opponent and subtracting the seed of the team we are predicting for. That way we know the difference. So, a 15 spot seed difference would likely indicate a greater chance of winning. Then finally, I set the win column. I create a win column and set it equal to 1, which means they win. Then I do the same thing for the losing team, except now it's 0 instead of 1. Put that data together, filter out some of these fields. I set the X variables to all of these except for win, seed, and seed opponent. The reason I did this is because there was some multicollinearity going on there. Look up that term. I will not do a good job at explaining it. Basically what it means is some of the fields were too related and was causing some issues. So, of course, because we have the seed opponent, and then the seed difference. Of course, those are related because they're calculated using each other. So I get rid of those, and I just keep seed diff because after some playing around, I found that was a variable that really mattered here. And then we set the Y variable to win because that's what we're trying to predict. We're trying to predict wins. Running through the ordinary least squared to filter out any insignificant variables, and this is what we end up with. Should probably add a constant. I had a constant. It didn't really make a difference, but should probably do that. Training this one, we do a lot better at predicting winners here. So about a 71% accuracy of hitting the winners here. As you can see in this confusion matrix, when we predicted a loss, we got it correct 46 times, wrong 21 times. When we predicted a win, we got it right 49 times, wrong 18 times. So that is just on the test variables and not the overall thing, because of course. Cool. After that, I made a quick function here that will take in the team IDs, the season we are predicting, and then each team's seed. Basically, what this function does is we are getting the data for each team, and we are calculating the win probability based on the on the logistic classification model we created above. So to kind of test this out, I went and I ran it on every matchup of the 2021 tournament. And long story short, scroll the whole way down here, it got to the final matchup here with Baylor versus Gonzaga, and it correctly predict Baylor to win. So that's a good sign here. There were, of course, a few wrong predictions throughout here. That's completely expected. what I am happy of was that it actually ended up picking the overall winner of Baylor, which is awesome. So cool. That's pretty cool there. I then tried a few different models just because that's what you do. You test pretty much every model you can or you think will matter, and you choose the best one. So from here, then tried to do it with a decision tree. If you are unsure what a decision tree is, again, please look this up. There's too much to explain in this video. That's not what it's for. So again, scikit-learn is going to do all the heavy lifting for me. I'm importing the tree classifier. We fit the data. We scored the data. Not quite as good as the logistic, but really not bad. About 60%. Then did a random forest, which I honestly probably butchered. There's definitely better ways to go about constructing this random forest. Long story short, only about a 20%. Wasn't great. Next, I went through the gradient tree boost. Got about 67%. This was actually our second best model. Final two models I tried out here was K nearest neighbors. That ended up being about 66%. And then a neural network. Again, I didn't mess too much with the neural network. Through experience, I didn't think it was going to end up being the best model. There's, of course, more layers I can add to it and make it perform better. I didn't take the time to do that. I was honestly just happy with the logistic model, and that was what I ended up going with. So here, for the 2022 predictions, they want the predictions to be in a certain way for this competition. So if we look at the valuation, they want it to look like this. They want it to be the season underscore the lower number team ID underscore the higher number team ID, and then the probability of winning for that first team. So really, that's all I had going on here. I built it into the function above to do that as well. I'm just appending that, and then I turned it into a CSV, which I will be submitting. But let's get to the fun part, the part that everyone cares about. Who's going to win this thing? What should I pick the whole way through? This is going to be 100% accurate. You should totally follow it. There's definitely a high percent chance that you will win $1 billion that Capital One puts up every year. That was all sarcasm. The odds are against you. You're not going to get a perfect bracket. Just accept that. But let's beat your friends in your bracket pool. That's really what matters, right? Let's win some money that way. So I'm going to run through the model picks for all of these. Now, a few things to remember here. One, these are predictions on who to win, and we are taking whoever has more than a 50% chance according to the model. That, of course, that makes sense. Now, when betting this, that does not mean you always pick the team that is, quote unquote, expected to win. That's not how you should be betting. You need to bet smarter than that. You need to be able to use the break-even percentage or implied probability, whatever you wanna call it. Check out our episode on implied probability to find out why that's just so important. So each day of the tournament, I will be tweeting out our bets. Now, again, remember, these are our bets we're taking. They are not the who we think will actually win. Now, that sounds ass backwards, right? But that's not, or back asswards. How do you say it? I don't know. It sounds contradicting, but that is how you should gamble. And for an example of that, I have this. So let me put in just one of these matchups here. All right, yeah, so here we go. So Bryant versus Wright State, that is a first four matchup. We currently predict that Bryant has a 38.16% chance of winning, which means if their odds are plus 162 or better, you take that bet. For Wright State, they have a 61.84% chance of winning. So you take that bet when the odds are minus 162 or better. So looking at their odds right now, Bryant is currently at plus 145. We would not take that bet, right? Because plus 145 is not better than plus 162. So if we compare those percentages, so if we convert those odds into implied probability, so 145, it's a 40.82% chance. However, we are only predicting a 38.16% chance. So given that is less, we wouldn't take that bet. On the other side, Wright State is currently at minus 155, which is a 60.78% chance of winning. And we will take that bet for anything less than minus 162. So we are going to take Wright State here in this bet based on how we make our bets with implied probability. Again, check out our episode on that for more details. So starting with the West, Gonzaga versus Georgia State. Gonzaga, of course. Boise versus Memphis. The model is taking Boise. Connecticut against New Mexico State is going to take Connecticut. Arkansas versus Vermont. It's taking Arkansas. Alabama versus whoever wins versus Rutgers or Notre Dame. It is going to take Alabama, and just to put you on that, it does actually pick Notre Dame to win there. Texas Tech against Montana State. Texas Tech to win that one. Michigan State against Davidson. Michigan State. Duke versus CS Fuller or Fullerton. It is taking Duke, so really no upsets here just yet. Let's just work through this whole division. So Gonzaga against Boise. Gonzaga's going to win that matchup. Arkansas versus Connecticut. Connecticut is going to pull the upset here, according to the model, and take on Gonzaga. Alabama taking on Texas Tech. Model's taking Texas Tech. Duke is going to beat Michigan State. Gonzaga taking on Connecticut. Gonzaga is going to make it through there. Duke is going to beat Texas Tech. And then Duke will be going to the Final Four after beating the tournament favorite Gonzaga. Moving to the South, Arizona is going to beat whoever wins between Wright and Bryant. Seton Hall is going to beat TCU. Houston beating UAB. Illinois beating Chattanooga. Michigan getting the upset against CSU. That is currently the biggest upset. An 11 seed beating a 6. Tennessee is going to beat, was that Longwood? Yep, Longwood. Ohio State beating Loyola Chicago. And Villanova beating Delaware. Arizona is going to go on to beat Seton Hall. Illinois beating Houston. Tennessee beating Michigan. Villanova beating Ohio State. Arizona beating Illinois. Villanova beating Tennessee. And then Villanova beating the 1 seed Arizona to go to the Final Four. In the East, Baylor is going to beat Norfolk. UNC is going to beat Marquette. St. Mary is going to beat whoever wins between Wyoming and Illinois State. UCLA is going to beat the cheaters, Akron. Texas is going to beat Virginia Tech. Purdue beating Yale. Murray beating San Francisco. Kentucky beating St. Pete's. Baylor is going to end up beating the UNC. UCLA beating St. Mary's. Texas gets an upset over Purdue. So my city team here beating yet another pretty high favorite. And then Kentucky beating Murray to go on to play Texas, where they will beat Texas. Baylor is going to meet them in the Elite Eight after beating UCLA, and then Baylor beating Kentucky, going to the Final Four. Kansas is going to beat the winner of Texas Southern or Texas A&M Corpus Christi. San Diego is going to beat Creighton. Iowa beating Richmond. Providence beating South Dakota State. LSU beating Iowa State, Wisconsin beating Colgate, USC beating Miami, Auburn beating Jackson State. So not a ton, really no upsets there at all. Kansas is going to beat San Diego State, Providence beating Iowa, Wisconsin beating LSU, Auburn beating USC, Auburn then beating Wisconsin, Kansas beating Providence, and Kansas beating Auburn, going to the Final Four. So not a single upset there. We have Duke versus Baylor in our first Final Four matchup. Baylor is going to go again to the championship game, where it will play Villanova, who's going to beat the number 1 seed, Kansas. And then finally, Baylor is going to do it 2 years in a row by beating Villanova. I just randomly put a number here, 69 versus 67. I don't have a clue. So that is what the model is predicting. Is it the same as you thought? Does anyone think differently? Now, currently, I think a lot of people think differently because Baylor, if we look at the odds, they're somewhat out of it. So if we go and we take a gander, Baylor is currently at plus 1,200. So 4 teams ahead of them. Gonzaga at plus 300, Arizona at plus 600, Kansas at 700, and Kentucky at 800. So pretty decent value there for Baylor at plus 1,200. That'll do it for this video. Again, be sure to follow us at Sleeping with the Numbers on wherever you listen to podcasts. Spotify is our preferred at the moment, but you can find us anywhere. We are everywhere. Subscribe to us on YouTube, Sleeping with the Numbers. Real easy to find us there. You can also follow us on Twitter at SWTN_podcast. You can follow me at Fantasy, PYANTASY. You can also follow our bets. We are on Action Network. I am at Fantasy, PYANTASY. Pat is at Pat_Fox. And the podcast is at SWTN_podcast. So if you want to follow our bets, that is probably the easiest way to do so. Also want to remind everyone, we have a bracket challenge going on. It is free to enter. It is on Sleeper. You can find all of the links in the description. All you have to do, be subscribed to the podcast, be subscribed to the YouTube, enter in on Sleeper, and you're in. It's free. We are giving away at least a $25 gift card to Amazon. I say at least because with every person who joins, other than myself and Pat, we will be adding an additional $1 to that amount. So, if there's 10 people in it, it's now a $35 gift card. That will go the whole way up to $100. So the more people in there, the larger the prize gets. So invite your friends, invite your family. It helps us out. We really appreciate it. And hopefully we all win some money together. All of those links will be in the description. And I hope to see you there. Best of luck.